Hello and welcome to this tutorial of SPSS, and in this tutorial we are going to show you how to conduct factor analysis, and we will also show you how to interpret the results of that analysis. Factor analysis is done for several purposes. The purposes are to study the interrelationships of the variables and to reduce the number of variables. When you have a huge number of variables, that makes your dataset complex to handle, and you want to know the effective variables to describe your subject or your dataset in a better way. So for variable reduction you can conduct factor analysis, and also you can find hidden or any latent constructs or variables if there is, just like there may be some unobserved variables. Those are not seen in normal ways, so those variables actually affect the other observed variables. In that case, you can run a factor analysis to identify those latent constructs. There are actually two approaches of factor analysis. One is exploratory analysis and another one is confirmatory factor analysis. If a researcher knows that there is certainly some factors, those are kind of latent or those are kind of ineffective for your to describe your data, or in that case you can conduct confirmatory analysis, and that confirmatory analysis is done after exploratory analysis. But when you have no idea about the factors, hidden factors or latent factors about your of your dataset, in that case you can do exploratory analysis. So after conducting exploratory analysis, you can identify some factors or latent variables in your dataset, and then you can run the confirmatory factor analysis. There are actually several extraction methods with which those factors are identified. Here I have listed actually three mostly used extraction methods: the principal components method, maximum likelihood method, and the principal access factoring. The maximum likelihood and principal access factoring, these two methods are almost similar. However, all the extraction methods are almost similar actually. They have little difference between them to bring the conclusion. There are actually two methods of rotation in factor analysis. The first one is orthogonal and the second one is oblique rotation. If you assume that your variables are having kind of correlation between them, then you should use oblique rotation. Otherwise, if you think that your variables are uncorrelated, in that case you will conduct orthogonal rotation. And variables are rotated to understand, to get more understanding about the variables. That's it. And after factor analysis, we retain some factor and we also exclude some factor from the dataset. The factor retentions are based on several criteria, and we will have the idea of factor retention when we will do a practical factor analysis. Let's see how we can do it. So here is my dataset. Here I have collected data from 120 people, and these 120 people, they have provided their answer of how many questions are there. They actually answered 12 questions, and these 12 questions are to describe a certain company, suppose like LG or LG product. I have asked them to mark the LG products based on their quality, and they mark the LG products based on their quality out of 100. They also mark the durability of LG products, and there is ease of functionality. They have marked this character of LG products. Then there is price, size, design, variation, packaging, advertising, launch time, sales point, and goodwill of the company. They have marked the LG products or the company LG based on these attributes or character of the products. So here I have actually 12 variables. Those are describing LG. But I want to know which of these variables are more effective than the others. Actually, I want to know the ineffective factors because they are not describing the LG in a better way. So what I will do, I will conduct a factor analysis. Let's see how we can do factor analysis. At first, we have to go to the analyze, then from dimension reduction to factor. These variables are also called dimensions. As we reduce these variables, this number of variables, or we identify the hidden variables, so this is called dimension reduction. However, you will find all of your variables listed on the left side. Just transfer these variables, all of these variables except the customer ID, transfer them into the variables box. Then just enter the descriptives. Here we will check coefficients, KMO and Parlet's test of sphericity, then click on continue. Then enter the extraction. Here at first you will find different methods of extraction, and these methods are to extract the ineffective factors or identify the latent constructs or factors. Here I will actually use principal axis factoring because this is a very new dataset and I have no idea about the ineffective factors inside this dataset. And here under display I will check mark script locked, and I will keep the other settings here as they were. And one thing we need to identify here that about this option, extract based on eigenvalues greater than 1. So we are going to identify the ineffective factors, and the ineffective factors actually will have their eigenvalues greater than 1. So that if any factor has eigenvalue greater than 1, then we can identify that factor that factor is an ineffective case for our dataset. That's it. Anyway, click on continue, then enter rotation. Here you will find the rotation methods. The first three, I mean the Varimax, Quartimax and Equamax, these three methods are orthogonal, and the last two methods, I mean the direct oblimin and Promax, these two methods are oblique methods. As I said, I assume that my data set is having correlation. I think my data set is having correlation. I mean my variables here. So I may use direct oblimin or promax because these two rotation methods are about correlated variables or oblique rotation. However, I'm using here the promax rotation and then click on continue. Then we have actually nothing to do with scores here, so keep it as it was. Then enter the options. Here I will check mark the suppress small coefficients, and here I will change from 0.1 to 0.3. It means if any coefficient is less than 0.3, that coefficient is assumed kind of ineffective for any data set. So here what I'm going to do, if any coefficient we find in the factor analysis less than 0.3, that will be ineffective here, or ineffective for our data set, or ineffective to describe the algebraic products. And just by checking this option, I'm saying that I'm instructing that if any ineffective coefficient is found which is less than 0.3, it will not be shown, because that will be helpful to know the effective, or to identify the effective variables. However, click on continue, then click on OK. So here is our outcome window. Let's expand this one. You will find correlation matrix in the very beginning, and this correlation matrix is about the correlations between the variables in our dataset. One thing you should keep in your mind that your dataset should not have any multicollinearity. And multicollinearity means correlation coefficient greater than 0.8. So if you have any correlation coefficient of greater than 8 here, in that case you should transfer those variables and bring other variables in their position. However, our main point starts from the KMO and Bartlett's test table. Here the rules about KMO test, or Kaiser-Meyer-Olkin sampling adequacy test, is that this KMO value should be greater than 0.5. If it is greater than 0.5, then your dataset is suitable for factor analysis. And the Bartlett's test results should be statistically significant for factor analysis. So what we see, our KMO value is 0.65, which is greater than 0.5. So our data set is suitable for factor analysis, and also the Bartlett's test of sphericity result is statistically significant. So we can interpret or consider the other tables in this outcome window of factor analysis. Then there is communalities table. However, we will come to this table to interpret after interpreting the next table, which is actually total variance explained. Here what we see from this table is that there are actually four factors here. Four factors. Those are ineffective to describe our main subject. 4 variables out of 12 variables, they are not describing algebraic products properly or in a better way. And these 4 variables are having eigenvalues greater than 1. So from here we are sure that there are actually 4 variables. Those are ineffective in our dataset. Then we can get more impression about that from the tree plot. Here the eigenvalues of each of the variables are shown. Each of the points are eigenvalues of each of the variables in our dataset. And what we see, the first factor, second factor, third factor, and the fourth factor. These four factors are having eigenvalues greater than 1. So this tree plot matches this table of total variance explained. Now we are going to interpret the communalities table. Here what we see, there are actually 2 columns, the initial and the extraction column. The initial column shows correlationship between a certain variable with the other variables in our dataset. So what we see, the correlation between quality and the other variables in our dataset is 56.1%. We can interpret another coefficient here, just like such as the goodwill of the company. The correlationship between goodwill of the company and the other variables here is 12.1%. And in that way you can interpret other coefficient values in this table, in this column. And let's see what extraction says. The extraction says we have already found that there are actually 4 factors. Those are ineffective. What the extraction says, the extraction values here describes the variance of a certain item explained by the ineffective factors. We have already got 4 ineffective factors in our dataset from here, and these 4 factors or ineffective factors, they can explain 83.6% of the variance of the variable named quality. Here if we interpret the extraction coefficient of size, it means the 4 ineffective variables or 4 ineffective factors, they explain 22.1% variance of the variable called size. So in that way you can interpret the other numbers here. However, we will actually filter the ineffective factors from communalities table. How we can do it? We have to look at the values under initial column. If any variable has coefficient value less than 0.3 under the initial column, that variable is an ineffective variable or a factor for our dataset or to explain our main subject. So what we see, the size, this variable is having coefficient value less than 0.3, so size is a ineffective variable here. Then we see that goodwill is another ineffective factor because it's also having coefficient value less than 0.3. So we have already identified 2 factors from communalities table. Let's mark these factors. I need a pen to mark the factors. We found the size and the goodwill. Then we will move to the next table, not factor matrix actually. We will move to the pattern matrix. The pattern matrix is kind of representation of some regression lines here. Here our variables are listed vertically and the 4 factors are listed horizontally. Actually what it says, the quality is a function of the 4 factors. This row is a regression line and this row is another regression line of durability. However, here the blank cells say that these values are actually less than 0.3. So these values are kind of not important for our case or for factor analysis. That's why these values are not shown. We have already instructed this during our command. However, we have to look at actually one more thing is that these values are actually called loadings. What we see, quality is loading into 1 factor, durability is loading into 1 factor, and we have to see here if there is any variable which is loading into more than 1 factor. So if any variable has 2 loadings, then we will mark that variable because that's having 2 loading, and that's kind of confusing. And also that certain variable is a ineffective case for our subject here. So ease of functionality, price, these variables are also having single loading. Size is also having single loading. Design variation, they are having single loading into factor 2, but the packaging is having double loading. Packaging is having double loading into factor 2 and factor 4. So mark this variable packaging. We have found the next factor out of 4 factors. The third factor, packaging. And the advertising, launch time, sales point, these variables are having single loading into factor number 3. Next, what we have to do, there might be another variable which we cannot we are unable to identify from this factor analysis. So how can we identify that factor? We can use the reliability test. Just go to analyze and from scale to reliability analysis, and here we will pass all the variables to check their reliability, and we may find more than 1 variables from here that may be ineffective for our to describe our subject here, which is the LG product. Just pass them in the items box, then enter statistics and check mark scale if item deleted, then click on continue and lastly click on OK. So here is our test result, and we have to look at the this column, correlated item, total correlation. And we have to look at in this column that if any item or in any variable is having value or coefficient value less than 0.3 or not. If any item here is having a value of less than 3, then that variable is certainly ineffective for our case. So what we see here is that this one, I mean the price is having value of less than 0.3. So price is another ineffective factor here. And also the size, we have already found size in our first step in the factor analysis. So mark these two variables, and goodwill is another ineffective factor which we have already found in our first step. So now what we have to do, we have to rerun the factor analysis without these four identified ineffective variables. Just go to analyze, and from dimension reduction to factor, we are now excluding our identified ineffective factors, which are price, size, then packaging, and lastly goodwill. Exclude them and then run it. So here is our second run. Here what we see from the KMO and Bartlett's test table is that KMO value is greater than 0.5, so our data or our data set is still a suitable one for factor analysis, and also the Bartlett's test result is still significant. Now from the we will look at the total variance explained here. For this second run, the SPSS software has not extracted any factor, I mean ineffective factor, which are having eigenvalues greater than 1. But the script plot is saying that there are actually 1, 2, and 3 variables. Those are still hiding inside your dataset. So I need to identify those variables. We have already found 4 ineffective variables and we excluded them, but there are still 3 unidentified variables. They are staying inside our current dataset. So let's look at the communalities table. If any of these variables is having value less than 0.3, and we see the ease of mesh functionality is another variable. So identified another factor, ease of functionality, and also the advertising is another one. So mark it as well. Then run the reliability test again from scale to reliability analysis. And for this second run of reliability analysis, we are going to exclude the size, price, packaging, and the goodwill of the company. Then click on OK. Here the correlated item total correlation table, and here from we will look at the values. Those are less than 0.3. So what we see, quality is the next ineffective item, so identify it, mark it, quality, and durability. And there's no other variables here, those are ineffective. So we are going to run our factor analysis for third time. just go to analyze, and from dimension reduction to factor. For this time we are going to exclude ease of functionality, then advertising, then quality, and durability. Run it. So we still have our KMO and Burles test results are okay. Our KMO is greater than 0.5, so data are still suitable for factor analysis, and this Burles test is still significant. Now what we see from total variance explained here, that there are two variables, two factors here that are kind of ineffective, and this script plot is also saying two variables are having eigenvalues greater than 1. However, let's look at the communalities table. Here all the values under the initial column are having their coefficient value greater than 0.3. So there's no ineffective values here. Then move to the pattern matrix table. There's actually no variables that is having more than one loading. Each of the variables are having single loading. The design is loaded into factor 2, and variation is loaded into factor 2. Launch time is loaded into factor 1. Sales point is loaded into factor 1. So all of these variables are loaded singly. And this is the end. What we did, we extracted 1, 2, 3, 4, 5, 6, 7, 8 variables. Those are ineffective to describe LG products or the LG company from this factor analysis. And to bring this conclusion, we ran factor analysis for 3 times, and each time we excluded some variables. So in this way you can identify the ineffective variables, or you can identify the latent variables inside your dataset. I hope this video makes sense, and if you have any question, please feel free to ask me in the comment section, or if you have any suggestion, please write into the comment section. And lastly, thanks for watching.